Okay, good day. So we will be continuing our discussion about fuel and energy efficiency innovations. So we will go to the topic two, energy recovery systems. So there are so many systems now um, used in this um, topic. Okay, so let's start. For marine engineer appears a person who solves problems you didn't even know existed by using precision guesswork based on unreliable data provided by those of questionable knowledge. Also see wizard or magician. So hindi lang tayo palangoy-langoy sa barko, we are also magicians on board ships. Okay, let's go. Introduction to Energy Recovery Systems, ERS. Okay, so energy recovery systems play a crucial role in improving energy efficiency and reducing carbon emissions in marine diesel propulsion. So these systems capture and reuse energy that would otherwise be lost, leading to fuel savings, reduced greenhouse gas emissions, and compliance with environmental regulations such as MARPOL, Annex 6, and IMO decarbonization targets. So let's go. Okay, letter A. So here are the different energy recovery systems used on board or that may be used. We can also use on board. Some of these ones are um, currently um, currently not used on board, but in the future they will be used. So, but most of these ones are already used in onboard ships. Okay, first let's go. Letter A, we have the waste heat recovery system. So, the purpose of this one is to utilize exhaust gases from the diesel engine to generate additional power. So it can converts exhaust heat into steam to drive a steam turbine generator, supplying electricity to ship systems, leading to fuel savings and lower CO2 emissions. So also the steam that is produced using the exhaust gases is also used in heating the fuel oil tanks, lubricant tanks, purifier, fresh water for domestic use, like for your shower, heating for the shower or other domestic use. So another term for this one are the economizers or the exhaust gas economizers. So economizers or exhaust gas boilers. So this is not economizer, exhaust gas boiler, EGB. Okay. So exhaust gas boiler or economizer, these are the most common terms used on board ship. And in general, these are waste heat recovery systems. As you can see, this exhaust goes into this economizer in here, and this economizer will produce steam for here going to the flush turbine. So this one. So if this turbine, this steam turbine will run, also a generator will run, and then this electricity will be used to power to supply electricity to the ship systems. Okay. So these are examples. We have here the engine, and then turbocharger going with the exhaust up. This is the economizer. Yeah, that's one. Also for generator. This one is the side view. Yeah. Okay, let's go with letter B. So letter B is shaft generator system. So what is this one? Uses mechanical energy from the main engine shaft to generate electricity. So it reduces fuel consumption, lowers greenhouse gas emissions, and improves efficiency, operational efficiency, especially during cruising speeds. So let's check how this works. So we have here the main engine. Okay, while the main engine is running, a shaft generator motor is also can be used to generate electricity. Shaft generator or motor. So this can be used as a motor, this can be used as a generator. And this shaft generator can create electricity, giving electricity to the ship service power, and then to be used on board ship. Okay. So this is the shaft generator system. Actually, we've discussed this in the um, previous um, discussions already. Next, we have the turbocharger energy recovery. So, as we all know, the turbocharger extracts excess energy from the exhaust gas to assist in driving the diesel engine. So, when an exhaust gas is driving the turbocharger, then since it is connected to a compressor, the compressor side will also run, giving more air to the engine, thereby assisting in driving the diesel engine, or assisting in increasing the efficiency, enhances combustion efficiency, and reduces fuel consumption for the engine, and reduces NOx emissions by optimizing air fuel mixing. Okay. So we already know about this turbocharger, so we will not dig deeper in here. We've discussed this in previous topics. Okay, so modern turbochargers are very efficient nowadays, which up to 70% efficiency. So these are the methods that we use for our turbochargers um, to increase our efficiency. So we will check or discuss this one by one. Okay, let's go. So actually, we have discussed this on our um, previous discussion already, but for the sake of the other viewers, we will discuss it again, or we will have it discussed again. Okay, we have here the waste gate. So waste gate on the air side blows off part of the charged air. If placed before the air cooler, air should be released to outside engine room due to high temperature. So for example, we have two types of waste gate here. We have for the exhaust. So if, for example, let's see here, or maybe we can write things in here. Yeah, it's okay. You can write. Okay, the exhaust from the engine goes here to the turbine of the turbocharger, and then going out to the funnel, right? But if the system checks that there is too much of this exhaust, which is very um, that the turbine may run very fast, or there will be overspeeding. So some of this exhaust you can have this a waste gate, so you can bypass the turbocharger if there is too much of this exhaust. Also, in the compressed air from the air compressor, here is the suction and then compressor. If the system can see that there is too much of this air, because maybe if it's too hot or something, then you can decrease, uh, you can bypass the hot air, okay, outside the engine. Okay, you can also have it here after the charge, in the charge receiver. You can also have a waste gate. Okay, so it depends on the engine. Okay, next. So this is the exhaust gas. Another waste gate. Another waste gate here. So waste gate valve is in here. This one. This one. So if there is too much exhaust, we will bypass the turbine side, and then we will go sideward here, going to the exhaust. So this is the turbine side. So we will not go to the turbine side if there is too much exhaust. You can bypass some here. Okay, so that's another example of a bypass. So this wastegate valve is controlled by the air in the compressor side. So if there is air in here, some of the air will, if there is too much air, so it can push this one. There's a spring in here, so it can push this one, and then closing the turbine side. All right. If you push this one, so it will be closed. But if you mhm, raise all. So if there is air going in here, through here, so this one will be pushed. So this is a spring. And then if this will be pushed, this exhaust can be closed. But if there is less air, so the spring will push here, push to the left, and then this one will be open. So less air means less exhaust is needed also. Okay, so this is used to balance the fuel and air ratio. So that's exhaust gas wastage. Okay, next we'll go with the variable nozzle ring. So this is the nozzle ring. Um, I replace it with a. Okay, so this is the nozzle ring. This is connected in the exhaust side. Okay, so this is the nozzle ring. This one. So this one, the one moving. Okay, so if you adjust the nozzle ring, there will be an adjustment to the airflow or the exhaust flow to the turbine blades also. So as you can see here, we have a uh, this one. So if the engine speed is too high, so you can fully open the nozzle ring. Okay, so this is variable geometry turbocharger. So this is the variable geometry. And then if the speed of the engine is slower, or a middle engine speed area, so since the engine is moving slower, so maybe so the exhaust is also slower. So what they do is they decrease the opening of the nozzle ring to maintain the um, high pressure exhaust going through the turbine, to maintain the turbine speed also. Okay, so even at different RPM, so you still maintain that speed of your turbocharger. So that's how they do it. Next, we'll go with the jet assist or lambda controller. So with this lambda controller, there are better. Okay. So in this lambda controller, we have here um, number 6, a solenoid valve start limiter. We have 4 jet system. Okay, so we have here jet system. So what they do here is they have this um, the fuel index. So what is fuel index? It is um, the rate of the amount of fuel injected into our engine. Okay, so if the fuel index is high, there is too much fuel. So what they do is they would also add inject 30 bar pressure or 4 bar. Here we have a reducer, 4 bar pressure of compressed air to the compressor side. So the purpose is this one is since the fuel is increased in the fuel index or in the engine, then the air should also be increased. And since the turbocharger cannot increase the air because it depends on the exhaust, so what they do is they add a compressed air system connected to the compressor side. So if the fuel increases, you also add air using the compressed air here. Okay, so that is jet assist or lambda controller. Okay, um, so this is the effect. So without jet assist, if you increase the fuel of your engine, then there will be black smoke that will go out because there is too much fuel. Okay, but if you increase the fuel while also increase the air, so you maintain the fuel and air ratio, and then there will be no smoke coming out of the fuel panel or the stack. Okay, so that's how jet assist works. Mhm. So advantages of lambda control reduces reduction of visible smoke in case of sudden momentary load increases on auxiliary engines, improved load ability, less fouling of the engine's exhaust gasways, limitation of fuel oil index during starting procedure. Hereby, heavy smoke formation is prevented during start procedure. So this can also be used during starting. If you limit the fuel oil index, you also control the heavy smoke. Okay, next we have the cutout turbines. So what this it means, you can, if you have 3 turbocharger, you can close these valves here so that you can only use 2 or 1 turbocharger depending on how your exhaust works. Okay, so possible in case of multiple turbocharger, used in case of slow steaming. So what is slow steaming? It is when your engine is running slowly because you are not really your ship is on its schedule, then, and there is so much plenty time before, and there will be no delay that will happen. So if you have plenty of time, you can slow down the engine, so less fuel, less running hours, less maintenance. And but the downside here is since you have a slow steaming engine, then you have also a low production of exhaust. So you cannot power three turbochargers at once. So maybe if you slow down the engine, you could also cut off one or two turbochargers so that you can still so that your turbocharger will still run optimally by reducing the number of turbochargers. But the speed of the turbocharger is als- always in its optimum running condition. Okay, so that's why when you cut out turbine, you can also use this in emergencies if one turbocharger is has a damage or is running wild. So you can also cut it using the cutout turbines. Okay, we have here the power turbine. Okay, so as you can see, so let's write something in here. Okay, so this is our exhaust gas receiver. Okay, and then exhaust goes to the turbocharger and to the economizer, right? Okay. So what if you have so many or so much of your exhaust gas? So what they do, they put another line here. So this exhaust gas will run the power turbine going again to the economizer also. But the connection or so the other part of the power turbine is connected to a generator. So this one is generator. And then electricity will be produced using the exhaust gas. And then this electricity will be given to the main switchboard to supply power to our bus bar. Okay, so that is the power turbine. So it is an exhaust turbine connected to a generator or up to produce power. So from the name itself, you will know how it works. You have an idea how it works. Okay, next, this is an example. We have exhaust in here going to the funnel, and then as this one rotates, an alternator will produce power for the main switchboard or for the bus bar. Okay. Next, we have the hybrid turbocharger. So we have here a much more complicated one. So we have so this is the engine. Okay, this is the engine, and we have here the exhaust. Then this exhaust will run the turbocharger, right? Going to the funnel. So this one will run, and then on the other side of the turbocharger there is an compressor, so air will be drawn in. Okay. And then on the it is also connected to a generator. So it is there's a generator in here. So here we have the exhaust. Here we have the intake of air going to the engine. We have here a generator or a hybrid motor. So a synchronous motor. So you can use it as a generator or a motor. Okay, so if you have extra exhaust gas, so you can use this one to create power to our main switchboard. Okay, but if your turbocharger needs power, you can also use this one. But in the diagram in here, there is you can only give power, not back. Okay, so this is only used for production of power, not this cannot be used for helping the turbocharger. Okay, so that is a hybrid turbocharger. So there is exhaust is the one running it, and then there is an intake of air, and there is also a production of electricity. Okay, so that's it for hybrid turbocharger. We have here the two-stage turbocharger. Okay, so where do we start in here? So intake, so exhaust, engine, here's the engine, and then exhaust goes on the first turbocharger, running this turbocharger, and then then the exhaust will run the second turbocharger outside to the funnel. And then on the other side, while the turbine side is running, there is also suction of air in here, going to the engine, going into the charger cooler, and then into the manifold, and then going to the next turbocharger, and then going inside the engine. So what's the advantage of this one? According to their data in here, we have the one stage turbocharger and the second stage two stage turbocharging. So for one stage turbocharger, we have here a data of our fuel consumption and our load factor. As the load increases, consumption decreases and then goes up more than the maximum continuous rating. Okay. But if you use the two-stage turbocharger, you have here the fuel consumption, which is lower as it increases. So the value in here, as you can see, there is this difference mm, of fuel consumption. If you use two turbochargers versus one turbocharger, so you have a better fuel efficiency and energy efficiency. Okay, so that's it for turbocharger. Let's go with another one. So there are so many systems in here we'll be discussing. Okay, next we have the air lubrication system. So the principle of this one is as water flows here, the air will be sucked on this part because the water is in a Venturi effect. And then water and air mixes at the bottom of the hull. So this bubbles is used to create a lubricating. It's like a lubrication property at the bottom of the ship to prevent or to reduce frictional resistance of the ship's hull. Okay, so injects air bubbles beneath the hull to reduce frictional resistance between the ship and water. It reduces drag, leading to 5 to 10% fuel savings, enhancing fuel efficiency. It also cuts CO2 emissions significantly, making ships more environmentally friendly. So that is air lubrication system. Some ships use blower, so there is a forced air is forced into the bottom of the ship to create air lubrication under the hull. Okay, so this is air lubrication. So air is um it's like a soft or it's like a sofa on the bottom of the ship. So air hull lubrication it reduces ship's frictional resistance through water by generating carpet of air bubbles under the hull. Also, with this one, less vibration, less especially for the cruise ship. Also, they use this one to lessen the vibration of the ship to have a better gliding um, capability in the ocean. Okay, so this one they uses compressors or blowers to form an air carpet under the hull. Okay, so this one are the so many air injectors, or what's the name of this one? So this one, the air goes out here at the bottom of the ship. There are two compressor used. So one compressor is used. This one is for backup only. So this will give air into the bottom of the ship. Okay, here. So there is this one. Bubbles will go out there. Also here. Okay, this is the front of the ship. So bubbles go back down, go there, go there. Okay. So there are so many things that they've done on their ship, thereby increasing the energy savings. So they have air lubrication, thrusters, steam turbine, and so many things too. Okay, so let's continue. What are the other things that they put? Okay, cruise ship of the future, they use LNG, so less cleanest burning fossil fuel. Mm. We have fuel cell technology can help reduce ship emissions. So fuel cells generate electricity by chemical reaction with very little pollution and using the air lubrication system reduces drag of the ship. Okay. Okay, let's go another one. We have a freshwater generator. So some of the excess heat in the engine is used to generate or to boil down the seawater in here. So if the seawater boils, then steam will go up, and then those steam will be cooled down again, and then after it cools down, it will be become a fresh water to be used on board ship for drinking, shower, or other domestic use. So how do they use this? They create a vacuum distillation. So they create a vacuum inside this evaporator, and then if there is vacuum, you also lower down the temperature of the boiling temperature of seawater. So you can create steam, or you can boil the seawater even at temperatures lower than 100 degrees Celsius, around 40 to 60 degrees Celsius. On some naval ships often combine both evaporator type and reverse osmosis type of freshwater generator system for redundancy. So if one fails, you still have one way to create or to generate freshwater on board ship. Okay, this one. We will not discuss this diagram much because we have discussed this on our separate um, discussion. This is a picture of the reverse osmosis. Okay, only the freshwater molecule can penetrate um, into the this filters. So there is so much filter, so microfiltration. So all the viruses cannot enter. Viruses and proteins, E. coli, small compounds, and other ions. So only freshwater molecules can enter. That's how reverse osmosis works. There's a very, very fine filter or a permeable membrane used. On some vessels, they use this enhanced turbocharger desalination technology. So high pressure pump, this one, high pressure pump sucks seawater into the reverse osmosis, okay, membrane at high pressure, okay, and then since this turbocharger is running on this side, there will be also a rotation on the other side, thereby sucking the waste from your reverse osmosis, and then give it or drain it or put it out back to the ocean. And then fresh water will be used on board ship. So that is enhanced turbocharger desalination technology. This is not a turbocharger for exhaust. This is a turbocharger for reverse osmosis. Okay, next F. So that is F. Let's go with G. G is gas turbine for LNG tankers. So since you are an LNG tanker, and then of course you have some, so your cargo are LNG, so you carry liquefied natural gas. So you can also use this cargo. So since it will evaporate due to heat exposure, instead of wasting this boil of gas, instead of removing it from the tank and then just putting it or spreading it into the atmosphere, so you can use it. It is used as a fuel in gas turbines, providing propulsion or electricity. So the LNG in here will your boil of gas. So some of the gases that will evaporate or are called boil off gas. They can, instead of putting it in the atmosphere, you can use it to run the gas turbine, and then that gas turbine can be used for providing electricity on your ship, or maybe you're gonna use it as a propeller, or you can combine it with a dual fuel diesel electric. So dual fuel diesel electric uses both natural gas and conventional marine fuels, allowing flexibility in fuel choice. So you can use the boil of gas in here for your dual fuel engine. You can use it for your combined gas turbine and steam turbine electric drive, or you can use it in your gas turbines. So benefit utilizes boil of gas, reducing fuel waste, lower emissions compared to diesel engines, meets IMO 2020 and MARPOL Annex 6 regulations on sulfur and greenhouse gas emissions. Okay. And then the exhaust in here you can also use to run a steam turbine. And then goes to the funnel, and then steam turbine generator will give electricity. Yeah, you can also connect it. Okay, G. Let's go with H. The steam turbine generator. So for a steam turbine generator, we have here the main engine, and then exhaust running the turbocharger, then exhaust going to the economizer. There is also a bypass, or if you don't want to use it. Okay. So this exhaust will create steam. Okay. And then this steam from the high pressure drum, this will be turned into steam. Okay. So this steam can go and be reheat into the economizer to create a superheated steam, and then this steam will run this steam turbine, and then the condense will go back to the drain tank. And then if this steam turbine runs, since it is connected to a generator, the generator will give electricity for the ship. So that is steam turbine generator. So benefits 5 to 15% fuel savings by reducing auxiliary generator usage, lower carbon footprint, reducing CO2 NOx and SOx emissions, improve energy efficiency, and so we have here a steam turbine and a generator. So if this steam turbine runs, the generator will also run, creating electricity for the ship. Okay. So this is super turbo generating system. So from the engine, we've already discussed this one. Going up there, and then the heat here from the water here is heated up, low pressure drum. Going to here, you can also run the using low pressure. You can also run this using the high pressure. It shaft generator motor. Okay, we have here the power turbine, main engine, shaft generator. We've discussed this already, giving electricity for our ship, and then power management system (PMS). We have also a power turbine connected to a steam turbine. So this power turbine can be a gas turbine, and then the exhaust here will run the steam turbine, and then the steam turbine will run a generator, and it can also give electricity to our ship other than the generator. So DG 1, 2, and 3. Okay, another concept. So they add the economizer, the the gas turbine, and the shaft generator ship for our ship electrical generation. So this their diagram. They have this monitoring, and you can also start the machineries in here. This is their program, their software. Okay, so we will continue. We'll go to the fuel cell and hybrid energy storage system. So, a disclaimer lang. So, hanggang H ata, HIJK, LMN, LMNO ata to. So, letter I pa tayo. Okay, next we have fuel cell and hybrid energy storage system. So, stability of the onboard power distribution system. So, energy management strategy. So, how they use this? We have the generator. So, the generator can give load to the ship load or to the propulsion. Okay. You can also use the ultra capacitor to power the ship. You can also use the fuel cell to power the ship or to charge your batteries. So you can use the ultra capacitor to charge your battery, your generator to charge your battery, and then the battery can also be used to power your ship, or you can connect to a shore supply or a grid supply on shore to power your load in the ship. Okay. You can also use the propulsion if it has shaft generator. You can also use its power to the load. Okay. So in this one, we have the fuel cell. Stability, So control of hybrid energy storage systems with batteries and ultracapacitors. So load scheduling and balancing, centralized power management system. So this is the fuel cell. So this fuel cell will be much more discussed on our next on our topic, which is the for the air pollution topic. Okay, so let's go with J. J, we have the smart kite or kite powered ship. So this is the kite. This one is dragging the ship. Increase, but of course the engine here is still running. The engine is running in here. But the smart kite or kite power, this smart kite, this is electronically controlled. So this smart kite will help in reducing the fuel consumption and energy recovery and increase energy recovery of the ship. The smart kite, harnessing the wind using smart kite. We have control cards in here. So this is controlled and electronically controlled, and there's a program. So we are not the one who is holding this kite, okay? Or some some names we have the sky sail. So this may be the brand name. Smart kite, sky sail, or other names maybe. Kite power smart kite. Yeah. This is part of the wind assisted ship propulsion. There are so many wind assisted ship propulsion we have here. Next, we'll go to the Flettner sails. So this is the Flettner sails. It's like a tube or a round cylinder on top of your vessel. Okay. So how do they use air in this tube? Okay, let's see. So the rotors, this tube is rotating. Okay, it is rotating. As it rotates, depends on if the wind is going here from the side of the ship. Since the tube is rotating, there is a motion of the air going to the um, motion of air going there. So the air will be go that there, but there is a lift in here, thereby pushing the ship forward. Okay, so how do they do this? Huge cylinders that rose from its deck and spun by a physical phenomenon called the Magnus effect. This is the Magnus effect. The spinning poles generated a propulsive force that carried the ship forward. It's the same force that footballers use to bend a corner kick, cricketers use to swing a delivery, and a tennis player used to hang the ball just a little longer in the air. So here, this is the ball. If the air is going in this part of the ball, why it's not moving? Okay. Why it's not moving? Oh, why it's not moving? It's not working. So as you can see, so it's not moving really in here. This is a GIF. I downloaded it, but it's not moving anymore. Okay, so let's just continue. Okay, so as you can see here, let's go back in here. This since my ball is not moving anymore, so we will go back here. Okay, if the wind goes on the side of the ship, and since this rotor sail is rotating, that what this one is rotating, so the air that moves on the side will uh, will rotate on this tube or cylinder slow, and then the slow moving air goes in here. There is a slight curve in here. The effect is, since it is rotating, this one is rotating, there is a lifting force going to the front of the ship. So the ship will move forward using this Magnus effect. Okay, I hope you understand. Maybe it's difficult for me to discuss, but I hope you understand how it works. You can also check this one um, online. Magnus effect. So these are Flettner sails because this was named by because of Flettner. He is the inventor of this one. Don't know the name. So Flettner. So Flettner made think of something using the Magnus effect on balls, and now we've used it in um, running this ship, or as it helps in running the ship. Of course, there's still an engine in here working, but this air will help or assist the ship propulsion. Okay, we have here a rigid or hard sails. So these are made from rigid materials, but there are many different systems, including foils and sails with flaps which can retract. So this one, so they just adjust the angle of this one depending on the wind. So it will help or assist our ship propulsion. So this one you can, if there is no air or the air is against you, you can lower it down like this one. So lower it down. But if there is a positive air that may help your ship, you can um, hoist it up. And then it depends on the angle of the wind. So you can rotate this one. You can rotate that one. Okay. So that's rigid or hard sails. We have soft wing sails. So these were the at the time at times of the pirates of the Caribbean, they are using this one, soft wing sails. You can also use this one maybe on smaller ships, but not on bigger ones. This one you can use the soft wing sails also. Traditional type of sail. Next, we'll go with the suction wings. So these fixed wings have vents and an internal fan to create suction. So they looked at how the wings of the birds work, and then using this data, they made their own suction wings. So air goes in here, and then here the vacuum chamber, thereby increasing the speed in here. Or you can also use this one. This one, there's an air, and then there is a blower inside that gives also air to increase your speed of the ship to assist your ship propulsion. Okay, so that's how they work. So there's an air from the outside, and then there's also air inside that is helping with the propulsion. So this one. So there's a blower, an air suction in here inside. Okay, helping in the there's thrust force. There's also using the are they using the Flettner sails also or not? So this one, that's how they work. Raise all. So that's how they work. There's an air pressure, high air pressure air source inside in here, going through these holes, thereby assisting. They add energy to the boundary layer by blowing high pressure air through holes or slots. On this one on the top, they have vacuum. So if the air goes here, it will be sucked in here, thereby increasing the sucking of air, thereby helping in the movement of the ship. Okay, next, letter O. Maybe this is the last or not. M and O. O. So let's go with the O. Wind turbines. So turbines available in both horizontal and vertical configuration. Wind turbines can be used to generate both thrust and onboard electricity. So as you can see, these are the wind turbines. There are different types of wind turbines. And then you can also install this in your ship to produce electricity or can help the propulsion, whatever. Next, we have the hull forms. So the hull design of the ship is used to create a using the air to move the ship forward faster or increase or help that or assist our ship propulsion. So they use the form of the hull. The hull is designed in such a way so it functions like a large sail underneath the vessel, capturing wind to generate thrust. Yan. So the Norwegian designers new concept for a partly wind-powered merchant ship, the wind skip or wind ship, which can cut fuel use by 60% and carbon emissions by up to 80%. So this is their design. Actually, these ships are also already running. So these are not just concept; these are being used today. Okay. Next, we have the marine grade solar panels. So this one, these are solar panels. So you can use this to power your ship, right? And they combined it with the rigid sails. So these are your rigid sails, and then you put a solar panel in this part. So yeah, it's a good way to lessen fuel consumption, better energy for the ship. So this is an example of the world's largest solar powered boat. This is a 115 feet Planet Solar Turanor. So these are solar panels on top. So many solar panels. So this is solar powered ship boat. So another company is developing various solutions to help the industry decarbonize, including rigid sails, marine grade solar panels, and energy storage modules. So they have their sails in here, energy sails. We have flexible solar panels installed, and this one will be used to charge the energy storage modules and BMS battery. And then this energy will be used to power the ship to create. This can also be used for propulsion, maybe. So the energy sail and Aquarius IMS, so they are using this Aquarius IMAS. And then energy sail can help the propulsion, and then the solar can charge the battery. Or so there are so many ways things to do or things to improve in our ship. Okay, so those are some of the examples. Some. Okay, so many. So those are just some of the examples we have for our energy efficiency and fuel efficiency. Okay, so why? What is the impact on environment protection and energy efficiency? So the impact of using these technologies, they have fuel savings. We have CO2 and NOx reduction, reduce pollution, and extends equipment life, like optimize energy use, reduces engine wear, leading to fewer maintenance costs. Okay, so those are the impact of using these technologies. So the role of energy recovery in maritime decarbonization 2050. So by integrating energy recovery technologies, ships can move towards net zero emissions, aligning with IMO 2050 goals through adoption of hybrid and fully electric propulsion systems, enhanced energy efficiency in LNG and hydrogen fueled ships, reduction of operational carbon footprint. So by 2030, so we have a strict new build and operation requirements, moderate carbon pricing, using this one, whereas HFO, MGO, HFO, LNG. For 2040, new builds and retrofits e-ammonia, blue ammonia, biomethanol. Okay, very strict design. And by 2050, we are having 50% reduction in absolute emission and 70% reduction of carbon intensity. That's the goal. In conclusion, energy recovery systems are essential in modern marine diesel propulsion as they reduce energy waste, enhance fuel efficiency, and minimize greenhouse gas emissions. So, by optimizing waste heat recovery, shaft generators, turbocharger systems, and air lubrication, the maritime industry can achieve a more sustainable and environmentally friendly future. That's it. So those are the energy recovery systems. We can also use this on our next topic. So the next topic will be fuel efficiency um, on our next video. Okay, so I hope you have learned something or so plenty about these energy recovery systems, and I hope to that you can use it when you go on board ship your knowledge. Okay, so see you on the next video. For our next topic will be fuel efficiency. Thank you and God bless everyone.